Have you ever wondered how the simple act of water flowing downstream can light up your entire house? Well, my friends, the answer to that question lies in the fascinating world of hydroelectric power. So what exactly is hydroelectric power? It's a type of energy harnessed from the force of falling or fast-running water, which is converted into electricity. In other words, it's a way of turning the kinetic energy of water into something we can use every day, electrical energy. Now let's imagine a large body of water like a river flowing downhill. As the water moves, it carries an immense amount of kinetic energy with it due to its mass and speed. But how do we tap into this natural energy source and convert it into something useful? This is where the magic of engineering comes into play. Engineers have designed a system that can harness this kinetic energy and transform it into electricity. This system is known as a hydroelectric power plant. These power plants are usually located near a water source, such as a river or a dam. The water flows through a large pipe called a penstock, which leads to a turbine. The force of the water spins the turbine, which is connected to a generator. As the turbine spins, it turns the generator, which then produces electricity. The electricity is then transmitted through power lines to our homes, schools, offices, and factories, providing the energy we need to light our rooms, power our devices, and run our appliances. It's a fascinating process, isn't it? The energy that was once just a part of a flowing river is now powering our entire world. And all of this is achieved with minimal impact on the environment, making hydroelectric power one of the most sustainable and reliable sources of energy on the planet. The magic behind this process, it's called the hydroelectric power plant. At the core of a hydroelectric power plant lies a massive structure, the dam. The dam is more than just a colossal wall of concrete. It is a magnificent masterpiece of engineering designed to harness the power of water. But how does it function in a hydroelectric power plant? Let's break it down. At its most basic, a dam's job is to store water. It creates a huge body of water known as a reservoir. This reservoir is essentially a gigantic battery storing energy in the form of water. Now, you might be wondering, how can water store energy? Well, it's all about position. Imagine you're at the top of a hill, ready to roll a ball down. The ball is at its highest point, filled with potential energy. The moment you let it go, this potential energy is converted into kinetic energy as the ball races down the hill. The same principle applies to the water in the reservoir. The greater the height of the water in the reservoir, the more potential energy it possesses. This is because the water has a long way to fall, and the further it falls, the more energy it can generate. This is why many hydroelectric dams are built in high, mountainous areas, where they can create a large drop for the water to fall. This stored potential energy is a powerful resource. But it's just potential, waiting to be unleashed. So how do we turn this potential energy into something we can use, like electricity? That's where the rest of the hydroelectric power plant comes into play, transforming the potential energy of the water into kinetic energy, and finally, into electrical energy. So, the dam, with its towering walls and expansive reservoir, is more than just a barrier. It's a crucial part of the power generation process, a key player in the transformation of natural resources into usable energy. This potential energy is the first step to generating electricity. And that's just the beginning of the journey. Stay tuned as we delve deeper into the fascinating process of hydroelectric power generation. Now let's delve into the powerhouse, where the real magic happens. In the powerhouse, we find the heart of the hydroelectric power station. This is where the transformation of energy takes place, where the potential energy of water is converted into kinetic energy and ultimately into electrical energy. Imagine a massive amount of water perched high above, behind the dam. This water holds tremendous potential energy due to its height and gravity. Now, this water is allowed to flow down a vertical tunnel called the penstock. As it descends, the potential energy of the water is transformed into kinetic energy, the energy of motion. This fast-flowing water, full of kinetic energy, then hits the blades of a gigantic machine known as the turbine. The power of the rushing water spins the turbine at high speed. The turbine is like an enormous water wheel, harnessing the energy of the flowing water. Now, here's where the real transformation of energy takes place. The spinning turbine is connected to a generator. Inside this generator, there's a shaft connected to a series of magnets that rotate within a coil of wire. As the turbine spins, it turns the magnets. This movement within a magnetic field causes electrons in the wire to move, creating an electric current. This electric current is the electricity that powers our homes, our cities, our world. From the potential energy of water through the kinetic energy of a spinning turbine, we have transformed this natural force into usable, renewable energy. This process is not just a simple conversion, it's a symphony of physics, engineering, and natural forces working together in harmony. It's a testament to human ingenuity, harnessing the power of nature to light up our world. The spinning of the turbine, in essence, is the heartbeat of electricity generation. So, we have a spinning turbine, but how does this lead to electricity generation, you may wonder? Let's demystify the magic of electricity generation. At the heart of this process is a crucial component known as the generator. When we think of a generator, we often picture a bulky machine that roars to life during a power outage. But in the context of a hydroelectric power plant, this generator is a much more intricate and sophisticated device. Inside the generator, we find two key parts: the rotor and the stator. The rotor is a component that rotates, driven by the mechanical energy from our spinning turbine. The stator, on the other hand, is stationary, hence its name. It's here, between the dance of the spinning rotor and the stillness of the stator, that the magic of electricity generation happens. As the rotor spins, it creates a rotating magnetic field. Picture a magnet spinning rapidly inside a coil of wire. This rotating magnetic field is like an invisible force, reaching out and stirring the electrons within the stator. The movement of electrons is what we refer to as electricity. It's a bit like making a cake. The spinning rotor is our mixer, stirring the ingredients, in this case, the electrons. The stator is our mixing bowl, holding the ingredients in place. And as the mixer stirs and whips the ingredients together, we end up with something new and wonderful. Our cake, or in this case, electricity. This process, known as electromagnetic induction, was first discovered by scientist Michael Faraday in the early 19th century. And it's this same principle that is at work in every hydroelectric power plant around the world, turning the force of falling water into the electricity that powers our homes, offices, and cities. And that's how a spinning turbine and a cleverly designed generator can take the raw power of water and transform it into the electricity that lights up our world. And voila, the birth of electricity. Let's recap what we've learned about generating electricity in a hydroelectric power plant. We've journeyed from the lofty dam that holds back a body of water, creating potential energy, down to the powerhouse where this energy is transformed into electricity. Remember how the dam, a true marvel of human engineering, plays a critical role in this process. It creates a height difference, or what we call a head, between the water levels. This head is what helps create the pressure needed to turn the turbine blades. And then there's the turbine, an equally impressive piece of machinery. As the pressurized water rushes onto the turbine blades, it spins them around. This spinning motion of the turbine is then transferred to the generator. Inside the generator, the real magic happens. The spinning motion of the turbine converts kinetic energy into electrical energy. It's here that electricity is born, ready to be transported to homes, schools, hospitals, and offices all around the world. But what about the impact of hydroelectric power? Well, it's a cleaner, more sustainable source of energy compared to fossil fuels. It doesn't release harmful gases into the atmosphere, making it a friendlier choice for our environment. Plus, it's a renewable resource. As long as the rain keeps falling and rivers keep flowing, we'll have a steady supply of water to generate electricity. However, it's important to note that while hydroelectric power has numerous benefits, it's not without its drawbacks. The construction of dams can lead to habitat destruction and the displacement of local communities. It's a reminder that every energy source has its trade-offs, and it's our responsibility to manage these impacts as best as we can. So now, when you flick on a light switch, you'll know the journey that electricity took to reach you. Fascinating, isn't it?